Hello, differential equation students. We're going to be using variation of parameters today. And this is a tough method. So what I'm doing here is I'm actually following example 1 of section 3.6. So you can follow along in the book. I'll also have the maple stored for this, so you can follow along with that if you wish. If we were just trying to solve that homogeneous differential equation, our solution would look like this. You solve the characteristic equation, you set up constants, etc. In variation of parameters, we're going to change those constants to functions. u1 of t and u2 of t. Now, I need to start taking derivatives. So we'll define dguess. You've seen this in videos before. There's our derivative. All right, note something. We've got a lot of terms because we've used the product rule twice, and we have derivatives of u1 and u2. This is going to get nasty if we differentiate again. So we're going to make a simplifying assumption. We're going to assume that everything that has a derivative in it is equal to 0. So I'm copying and pasting these two terms that have derivatives in them. And I'm going to assume that those equal 0. That's our simplifying assumption. Now when we do that, we're also going to say what dguess is equal to. So dguess is now going to look like just that term plus just that term. So this is a simplifying assumption, but it'll make the rest of our life easier. Well, for the next couple of minutes anyway. So now I need to define what ddguess is. And of course that's going to be the derivative of dguess. Okay, now notice, I now can plug all this stuff back into the differential equation. I'm going to call this equation 2. So that's going to be the second derivative, ddguess, plus 4 times the original function, 4 times guess, equals the right-hand side, 3 divided by sine of t. Great. Please note, I have equation 1 and equation 2 that both talk about the derivative of u1 and u2. So I'm going to treat these like a system of equations and ask Maple to solve them. Please note that what I'm solving for here is the derivative of u1 and u2. I know this is kind of hidden right now, but just give me a second and this will show up. Go Maple, go. Go Maple, go. Wonderful. Simplify that. That's kind of nasty looking. So much better. Please note what's happened here. Hey, I have these formulas that tell me what the derivative of u1 and u2 are. Well, heck, I now know what u1 of t is. Because it's just the antiderivative of that. That's negative 3 sine of t. Maple's going to complain, and I'm going to say use that as a function definition. Cool. So I know what u1 is. Here's u2. It's anti-differentiated. Make sure we're doing that with respect to t. Go Maple, go. Fantastic. That's u2 of t. Isn't that ugly? My goodness. Function definition. Yep, that's fine. Now just note something. Remember, we were saying that we wanted our guess looked like this. We need to know what u1 and u2 were. Well, now we know. In fact, right now, if I type in guess, Maple will plug in. There's the u1 right there. And that horrible, horrible thing, that's the u2 right there. And that's going to be the solution to that non-homogeneous differential equation. So again, just kind of summarizing what we did here, what was important was making this simplifying assumption and saying that when we take the derivative of guess, everything that has a derivative in it, we're going to take all those terms and set those equal to 0.